We've been talking about graphing absolute value functions. Now we're going to shift to talking about absolute value equations. Before we do that, let's kind of connect the two. So we're going to solve this system of equations by graphing. We've just got done graphing absolute value equations like this. So let's go ahead and graph that real quick. There's my vertex and our slope. Down 2, down 2. So it'll look something like this. And y equals 3, remember that is a horizontal line at y equals 3. So I graphed both both equations of the system. And remember where the intersection is your solution. This has two intersection points, that I put in red. So there's actually two solutions to this system of equations. One solution is -2, 3. And another solution is right here, 0, 3. So remember, just when you're graphing a system, the solutions are where the graphs intersect. And in this case, we have two intersection points, so there are two solutions. Remember when we did linear systems, we could have one solution, no solutions, or infinitely many solutions. So we're also going to talk about how many solutions these absolute value equations could have. Now here are the steps to solve an absolute value equation. And I'm not going to read these right now. I'll read them as I do examples 1 and 2. But we do have a new term here called an extraneous solution. And what an extraneous solution is, it's a solution that does not work in the original system. So you do some algebra work and you get your solution, and when you check it, if that solution doesn't work, then that is an extraneous solution. So let's go ahead and solve example number 1. And like I said, as I solve it, I'll be referring to these steps up here. When we would solve any equation, we wanted to get x by itself first. Absolute value equations are the same way, except we need to get this by itself first, the absolute value bars. So we have to do the algebra to get that by itself. So we'll subtract 5 from both sides first. That gives us -2 times the absolute value of x plus 1 equals -2. Then we're going to divide both sides by -2. We get the absolute value of x plus 1 equals -2 divided by -2 is +1. All right, so now we got the absolute value bars by itself. The next thing we need to do is to split this up into two equations. One of them will be x plus 1 equals 1. And the other one will be x plus 1 equals -1. Because remember, once you are done with an absolute value bar, an absolute value, that changes whatever you have on the inside must be positive. So, for example, we talked about this before. If inside here equaled -1, well, once you take the absolute value of that, it would become a +1. So that's why we have this pink equation over here. So we're going to solve these two equations separately. Subtract 1, we get x equals 0. Subtract 1, x equals -2. Now, when we check our solution, we want to go up here to the original. And I'm going to get my calculator out since I'm running out of space here to check this solution. So check both my solutions, -2, and then absolute value of x, which we said one of the solutions was 0, plus 1, and then plus 5, and we should get 3. All right, so x equals 0 works, and then we need to change this to a -2. And we also get 3. So both solutions work, both x values that we got here work. So I'm just going to put a check mark here. Now, what do you notice about example 1 and our warm-up? Well, example 1 has solutions of 0 and -2. Look up here, -2 and 0 were the x coordinates of our solutions. Right? So what we could have done is down here graphed the left side and the right side separately and looked to see where the intersection points were. Using that knowledge, we could say that an absolute value equation could have two solutions like we have here. What if the horizontal line went this way? Okay, well then that would just be one solution. What if the horizontal line was up here? Well, then there'd be no solutions. We wouldn't have any intersection points. So you could have two solutions, one solution, or no solutions to an absolute value equation. If down here, if this equaled, say that equaled 10, you would find that there would be no solution to this. All right, example number 2, we already have the absolute values by itself. So we're going to 15 plus m equals -2m plus 3. And then we're going to do 15 plus m equals, and you got to be careful here because we're going to make everything here negative, not just the 2m. We're going to make everything negative by multiplying it by -1. And that's going to be positive 2m minus 3. So we're going to solve these two equations. So over here, we'll add 2m to both sides. Oops. So that's going to be 15 plus 3m equals 3. Subtract 15 from both sides. And we get 3m is equal to 12. Sorry, -12. Divide everything by 3. M equals -4. Then over here, we will add 3 to both sides. We get 18 plus m equals 2m. Subtract m from both sides. We get 18 equals m. So then we're going to check our answers. And this one's going to take a little bit more time to check in our calculator because the right side of the equation doesn't equal just 3. It's -2 times m plus 3. So what we'll do is absolute value of 15 plus m, which is -4, and that gives us 11. Now we're going to do -2 times m, which is -4, plus 3 is 11. So we know m equals -4 is a solution. And then we're going to do The same thing up here, where m was 18. So the absolute value of 15 plus m, which is 18, equals 33. Then negative 2 times m, which again is 18, plus 3. And we get negative 33. Those are not the same. So this is not a solution here. This is your only solution. M equals negative 4. That is why it is important for you to check your solutions and not just think, oh, m is negative, that means it has to be or it can't be a solution. Got to go through each of them to make sure. Okay, now, the last one we'll do together is this one right here. So we do not have the absolute value part by itself, so we're going to subtract 3 first. And we get 1/2 times the absolute value of 4x plus 12, close the absolute value bar, equals 11 minus 3 is 8. And then to get rid of that 1/2 out in front, we're going to multiply both sides by 2. And we get 4x plus 12 equals 16. Now we can set this up as two separate equations. 4x plus 12 equals 16. And 4x plus 12 equals negative 16. And we'll solve those separately. Subtract 12 from both sides. 4x equals 4. And when we divide both sides by 4, x is equal to 1. Then over here, subtract 12 from both sides. 4x equals negative 28. And when we divide both sides by 4, we get x equals negative 7. Okay. So then in the calculator, luckily we don't have to plug in anything on the right side. It's just equal to 11. But we do have some work to do up front. So 1 over 2, and then absolute value 4 times x, so 4 times 1 plus 12, and then outside the absolute value plus 3, and we want this to equal 11. Okay, so x equals 1 works. Now we got to try negative 7. And that equals 11 as well. So both of these are solutions. These both work. So what I want you to do in a minute is I want you to try this problem here on your own. And then down here, I want you to solve this equation on your own. Once you solve both, unpause the video, and then you can check your work with mine. And then I will show you how you could use the graphing feature of your calculator to verify your solutions instead of the way I originally showed you. So go ahead, solve examples 2 and 3, and unpause it when you're done. All right, here are the answers. So for this one here, you should get x equals 5 and x equals negative 1, and x equals negative 1 did not work, but x equals 5 did. So there's only one solution. And then down here, you got something interesting here where none of the solutions worked. We haven't had one of those before. And when I show you the graph, you'll see what that looks like. And I'm also going to show you kind of a shortcut that you could have used. So up here, again, are steps to do what I'm going to show you in the calculator in case you forget. Let's try those steps with this here. In my graphing calculator, I'm going to graph the left side. 4x plus 10. And in y2, I'm going to graph 6x. And then graph. And we see that the intersection point isn't on our graph, but we do notice that it's going to happen up here somewhere. Let's adjust our window. Our y value needs to be a little bit larger, our y max, so let's make this 30. And see if we can see the intersection point at that point. It's getting there. We can kind of see it, so let's go a little bit larger. And we want to find that intersection point. And to do that, we press second trace, go down to the fifth one, intersect. And we want to move the flashy thing, the cursor, close to the intersection point. It doesn't need to be exact, but you want to be close, because if there were more than one intersection point and you don't move towards one or the other, the calculator won't know which one that you want. Then we press enter 3 times, and we see the x value is 5 and the y value is 30, meaning that is our one solution, x equals 5. Now let's look at this one. We should see that there are no points where the two graphs intersect because there are no solutions. So the first equation will be 5 plus 2, and then the absolute value of x minus 4. And then the second equation would just be 1. And when we graph this, we should see that these two do not intersect at all. See, there's no intersection point there. And we can kind of zoom 6, or standard window, to see that. Now, an easier way to tell this without graphing, without solving, is once you get to this point here, you got the absolute value part all by itself. It says the absolute value of x minus 4 equals -2. Remember what we know about absolute value. Once you take the absolute value of something, you will get a positive number. So the absolute value of anything, absolute value of 55, the absolute value of -71, those are all positive numbers. What this is telling us right here, what I circled in red, is that once I take the absolute value of x minus 4, that value needs to equal -2, which can't happen. So you could get to this point here where I circled and say there's no solutions at this point, and you'd be done with the problem. So that's it on solving absolute value equations. You have a lot of ways that you can verify your answers. You can verify it graphically. You can verify them by plugging them in. Whichever way works for you is okay with me. And again, you have the directions here in case you forget how to do it on the graphing calculator, or you forget how to do it, forget the steps how to solve it. You could plug in your x values and do it algebraically, and there's nothing wrong with that either. I just didn't do it because I didn't have the space. But you could instead, 4 times 5 plus 10 equals 6 times 5, and do it that way. I'm okay with you doing it like that if you want to. So I hope that this gives you a good start on solving these absolute value equations. Thank you for watching. Make sure to like and subscribe.